back to PHP 101. In this lesson, we're going to be getting into database design. And I wanted to do this before we get into the code because, you can learn all the code and figure out how to do that whole part of it when it comes to MySQL. But if you don't have a good idea of how to structure your database, how to put your object model together, and really the main thing that I want you to get out of this lesson is a consistent process for doing that with every application you build. If you don't have that, it can be really hard to build a really good application, a scalable application, and an easy to work on and upgrade application, because that structure tends to get in the way. And the way to really think about this, and I'm going to get more into this as we go through, but really you shouldn't start with the code. Your object model really determines your data model or your database structure, which then ultimately determines your code and how you have to write it. So the code is actually several layers down the line. There's some things that you need to do before that. And once you do that, the code kind of tends to write itself. And just real quick, a quick story. This was one of the big aha moments for me. When I first started trying to build applications, I didn't understand the different kinds of tables and things that we're going to talk about here. And I was kind of creating object tables where I would have maybe 30 columns in a table, and I was trying to put all of the information that was related to a particular object into one table. And then if you're working with a blogging application, for example, and you have a post record, you might try and put categories in there, and it just starts to get really cumbersome trying to do it all in one table. And so I started actually studying WordPress to see how it was done, because one of the first big applications I built was a CMS. And I started to see that this kind of structure, and I looked at some other ones. I started to notice a pattern of how they were done. And then I kept going into object modeling and data modeling, and ultimately kind of figure out how this all comes together. So I wanted to give you that in this lesson, because I know for me it was a big aha moment. I know for you, especially if you're kind of just new starting out, this could be an aha moment for you as well. And I want to help you to be able to build applications that are scalable, they're flexible, they're easy and fun to work on, instead of being these big cumbersome things that you have to deal with. All right, so why does this sort of thing matter? Well, the thing to get is that your database structure represents your upper limit in terms of the flexibility, the scalability, the scope, the clarity, the ease of upgrade of your application. Your database structure is really what determines that. It's not your code. Your code flows from both your object model and your database structure. So if you get your database structure right, if you build it for flexibility, for scalability, and all those things, then it's going to make your life a heck of a lot easier. And so that's one of the reasons why we want to do this. And as I said, the more modular and flexible your database structure is, then the easier it's just going to be for you to scale your application. And getting clear on your data model, your database structure first, makes writing your code much easier. The code almost kind of writes itself once you have this stuff in place, because you kind of see how you need to connect it all together, and it's your code that ultimately does that. And as I said, your code is really secondary to your database structure. The structure of your database will determine how you're going to have to code, what kind of code you'll have. So what you want to do is make it easier on yourself. And you want to develop a database structure that makes the code that you have to write cleaner, clearer, more efficient, while keeping it all still really flexible and scalable. So we're going to talk about your object model, maybe something you may have never worked on or dealt with before. We're going to talk about the 3 different types of tables that you must have, and we're going to talk about your data model. And really what I want you to get from this whole thing is a consistent step-by-step mapping process that you can follow for every application that you build. So you can go through this exact same process for every single application that you build. Now, as you do it, you'll start to see that there's patterns, and so you don't necessarily have to repeat the work, but it gives you something to rely on when you get into building an application that maybe is new to you. It's a different kind of application. You still have a reliable process that you can work through. All right, so it all starts with an object model. So what is an object model? Well, first consider that every application you build will ultimately be a collection of objects that have certain properties, can perform certain actions, and have certain relationships with other objects. So the object model is the blueprint of your application. It's the objects that you're going to have in your application. It's the properties those objects are going to have. It's the actions those objects can take, and the relationships between those objects. So for example, if you were to consider a blogging application, now a really, really simple blog application would likely consist of, say, a user object, a post object, and a category object. And the post object might have the properties title, content, date, status, and so on. There's obviously a ton that you could add there, but those are some kind of ones that are tried and true that'll usually be there. And the post object may have relationships with the category object. So you may want to say this post belongs to this category or is in this category. That's a kind of relationship. Okay. And so the user object, as another example, may have properties, the properties username, password, email, etc., and be able to perform the actions, create post, edit post, delete post, view post, create, edit, delete, view, categories, all of that stuff. There's lots of actions that the user ultimately could perform. The object model is you laying all of this out. You creating a kind of roadmap of exactly what objects you're going to have, what their properties are going to be, the data you're going to collect on each object, the actions they're going to be able to take, and the relationships they're going to have with any other objects that you have out there. So if we were to kind of take a look at this, this is an example object model. So you can see on the left side, we have our three different objects. We have post, user, and category. And for post, we have the properties title, content, date, status, type, author. And again, you could go on and on. But properties are really meant to be things that are required for that particular object, meaning they have to be there. That information is required of every single one of these objects that you make. And you either have it entered explicitly by some sort of user or it's generated automatically. So you need a title, you need a content. You can say that you need a date, a status of, is it a draft, is it published, the type of object, type of post is. Now, this is kind of something, again, unique based off my WordPress experience, because you actually have different post types in WordPress. So you have posts, but you also have pages. They're actually the same object, but they're just a different type. You have the author here and so forth. So again, these are all of the different properties that you might have that are really required for this object to be able, an instance of this object to be able to exist. So in your database, the record for each individual post would require, it would need to be filled in with each one of these pieces, these property elements. All right, a post in terms of action, a post can't actually perform an action. It has actions performed on it by the user, so there are none. And then it's possible that it could have relationships with a category. If you're doing tagging, you could have with tags. There's an argument there for users. You notice we have the author and the properties area. You could technically create, we'll get into this, but you could technically create a relationship table and do it that way. Most of the applications I've seen, they'll actually put the author in the post properties. So there's some wiggle room there, but again, you would have different relationships that your post might have with other objects. The user object, so its properties are login, or you could maybe say that's its username, the password, the name, the email. Again, you could add to that list if you wanted. It's going to be the primary thing performing actions. So it's going to be able to create posts, edit posts, delete posts, view posts, create categories, edit, delete, view categories, all sorts of things that the user is going to be able to do. So most of the biggest chunk for the user is probably going to be the actions block. And then relationships that it could have relationships with the post. And again, you can either create a relationships table or you can put it in the actual properties of that other object. When you start to have a more complex relationship set, that's really when you want to get into a relationships table. And we're going to talk about the three different types of tables here in a second. So the category object, again, the properties, ID, name, slug, and so on, can't perform any actions, and it will almost certainly have relationships with the post object. Okay, so again, this is really just a map of all of the different objects you're going to have, the properties that you're going to collect, the data you're going to collect about each one, the actions they're going to be able to perform, and the relationships that they will have with other objects in your object model. Okay, so this is important to kind of lay out. So you can go ahead and print this particular page off. I've given you kind of a simple grid here that you can use to kind of write this down or type it in or however you want to use it. Of course, you can make your own. You can use an Excel spreadsheet whenever you're doing your mapping. But really, these are the key things to kind of know and lay out ahead of time before you ever start writing any code, so that you have kind of this laid out, and you know, again, what objects am I going to have? What are the properties? What are the actions? And what are the relationships? This is, again, kind of the blueprint of your application. All right. So now, once you have that, then you want to map essentially your object model into your data model. So what is a data model? Well, the data model is your application blueprint at the database level. So it deals with how the data will ultimately be stored in your database. So if the object model is kind of a map of your application of, hey, this is the blueprint of what it's going to look like, your data model is really it's a map of your database and where ultimately that data that you're going to have to collect based on your object model is going to be stored. So essentially you map your object model to your data model, detailing where the properties, the meta, the relationships, all of that is going to be stored. So for example, the properties of each instance of your post object may be stored in a table named users. Okay, so or in a table named post. That would make sense because that's where all your post data is. And it may include things like title, content, date, and status. It may have relationships to the category objects stored in a table named post categories, and that would show you that XYZ post belongs to XYZ category. Okay, so this gets us to talking about the three different types of tables that you would have in any sort of database structure. The first one is an object table, and that's going to store all of your properties about a particular object, and that's going to be really the name of the object. So in this case, for the post object, it may be posts or posts, right? And the second one you're going to have is a meta table. So meta is optional data about each one of your objects. So you may have a post meta table. And the reason this is important is because it helps create that first layer of flexibility. Okay, because there may be certain instances of a particular object. So there may be certain posts. Let's say you have 10 posts in your blog. There may be some of those posts that have certain data and other posts don't. If you're familiar with WordPress and you look at a good example is from a plugin. Actually, if you look at a WordPress plugin, WP SEO or Yoast SEO, what it allows you to do is specify a focus keyword. It's an SEO plugin. It allows you to specify a focus keyword, and it will analyze your title, your post content, all the data you've entered. It will analyze it and give you advice on how to make it more SEO friendly. Well, you don't have to enter a focus keyword on each post. You can create a post without entering that focus keyword. So that's optional data. Whereas you can't really create a post without a title. You can, but it'll just create a thing that says like no title. Okay, or you can't really have a post without content. Yes, it allows you to do that, but it still creates that entry and just leaves it blank. You can't really have it without a date and so forth. So there's some data that is really meant to be there for every object: title, content, date, etc., author. And then there's some that is purely optional. Really, it could be there, it doesn't have to be. It may or may not. The post can, or the object can go on without it. That's what you put in a meta table. So Again, for an object, you may have a post and post meta table, user meta table, category and category meta table. Okay, those are all things that you could have depending on your object, and you think you're going to have that kind of data for each one of your objects. The third type of table then is a relationships table. And a relationships table is how you tie two different objects together. So that's how you say, okay, this post belongs to this category. And oftentimes there's really only two columns in a relationships table, object 1 ID and object 2 ID. And what that essentially is going to allow you to do is you're going to have the ID of your post, okay, your post ID. So let's say post, record 1 is in the first column, and in the second column you're going to have category ID. And so you would have the ID of that category, which is 1. So you'd have a 1 and a 1. You'd have object ID, category ID, then you'd have 1 and 1. Or maybe you want to put it in the second category that you created. So that would be number 2, or the one with the ID of 2. You'd put a 2 in that column. And you would actually have, for post 1, it could have multiple records. So it'd be the first column you might have the first 3 records be 1, all referencing post ID 1. And then you'd have different categories for each one of those. So you might have, in the first record, it would be post 1, category 1. Second record would be post 1, category 2. And then the third record would be post 1, category 3. That would show you, what that's telling you is that post is in all 3 of these categories. Now, the reason you do it this way is it's simply a much more flexible way of managing these types of relationships, because it doesn't tell you what kind of relationship it is. The context of your application does that. Also, since you're referencing another object, you have a whole other table for the categories that you can then put a bunch of property elements in about that category. So you can store a ton of data about each one of those categories. If you were to try and let's say you say, I don't want to do that. I'm going to just say that, post 1, I'm going to create a category column in my post table, right? And I'm going to list the names of each category that it belongs to. Well, you would have to try and pack all the data about that category into that column. Or, if you don't want to create the relationships table, you could technically put a category column and put a 1, 2, 3 in there. Say it's referencing these category IDs, and then have your category ID as well. But having the relationships table makes it so that you can easily, you don't need to pull a whole record from your database in order to change the categories or mess with that stuff. You have a simple, concise, efficient relationships table that allows you to change what category something belongs to and manage it and so forth. And it's just really simple and a lot more flexible. So those are the 3 kinds of different tables that you could have. And those all go into helping you create your data model. So in order to create your data model, then there's really kind of 4 steps to it. First, you want to create your object table. So create a table for each object in your object model, whatever they happen to be. So for example, in our blogging application, you might have a post table, a users table, and a categories table. Now, if you want to prefix those like WordPress does, feel free to do that. So that would be WP post, WP users, WP categories. So that's the first step. For every object that you've laid out on your object model, create a table for it. And inside of it, then step number 2 is to map the properties. So turn the object properties that you laid out in your object model into the columns in your object table. So for our post object, you would have a table named posts, and the columns in that table would then be title, content, date, status, etc. You also want to make sure to include an ID field that auto increments, and I'm going to get into showing you kind of how to do all this in the code and so forth. But you want to create an ID field that auto increments. This allows you to create an index so that each record that gets stored in your database has a number associated with it, and that's its ID. So that becomes important when you start using the relationships tables and the meta tables and so forth, because you're going to be constantly referencing that ID, the ID of the object that you happen to be adding meta for or building a relationship for. Right? So again, map those properties in that table. Step number 3, you want to create a meta table for each object. Now you can analyze this. You can decide whether you need a meta table or not. Some objects might not need a meta table. It might not make sense that there's going to be this optional data added to it. I would say most cases having a meta table is probably going to turn out that you'll need one. You'll have certain data that's just you want to be able to add to some and not others, and not have it be kind of a big mess. Okay, so create your meta table for each object, and that's going to allow you to, again, that'll give you that initial flexibility to your application. Step 4, then create your relationships. So for every object, every 2 objects that are going to have a relationship, you need a relationships table. So for example, if you're going to have posts and you're going to have categories, you need a relationships table just for those two objects. So you'd have a post underscore categories table. If you're going to have tags, and you're not going to go all crazy like WordPress does and create this whole taxonomy thing to try and smush them all together, you're just going to have a categories object and a tags object. Well, you would also need a post underscore tags relationship table. So you'd have one for posts and categories, you'd have one for posts and tags. If there are any other objects that have any sort of relationship that you need to tie together, that you want this object to belong to this other object, you need a relationships table for each one of those relationships. Okay, so create those relationships table, and then, as I mentioned before, you're really normally only going to have 2 columns. You're going to have object ID, object 1 ID, and object 2 ID, and you're just going to tie the 2 together that way. Now, it is true that you could create other columns that could add information that describe the relationship in particular. Usually that comes from the context of your application, your code, and you don't have to, but sometimes you may need to add some information that describes the relationship itself. Not either one of those objects. Any of that stuff should go on the object or the meta table. But if you need to describe the relationship in particular, then you can add another column that will then, there would be some way of describing that particular relationship in each instance of that relationship. I've really only ever seen this, I think, once, and it was in WordPress, and has to do with their term taxonomy layout, the way that they do that. I've seen some auto load stuff and some other applications and so forth, but it's pretty rare. And in each one of those cases, this was only one extra column that was added. There wasn't a ton of different columns, because usually, again, you don't need to specify a ton of information about you don't need to say much about the fact that this post is in this category. It's just in it or it's not. There's not necessarily a ton of information to describe about that. So one example of where you may do that is, I know in WordPress, I think this actually comes from Yoast SEO. I've been running them both so long, I don't always know who added what, but you can set a primary category for each post. That would be an example of extra information that's describing the relationship. So the relationship of post 1 and category 3, you would have another designation, another column that marks that as primary. So they actually use it for when they do, Yoast uses it for when they do the breadcrumbs that they automatically add to your WordPress site. And so it has you pick one as the primary, and that's the one it shows in the breadcrumbs. So you may have something like that where, again, you need something that extra information that describes that relationship in particular. All right, so that's how you create your data model. Create the object tables, map the properties, create your meta tables and the data that would go in those, and then create your relationships tables. All right, so here's an example kind of database structure that you might see. So you would have a post meta, and a post categories tables. Post is obviously an object table, post meta a meta table, and then post categories is a relationship table tying posts to categories. Then user and user meta, and then you would have categories and category meta. And so that's an example of a database structure that you might see for a simple blogging application. All right, so hopefully that gives you some sense of how to create an object model and then map that to your database structure, so then you know exactly how to lay out your database. And it's really kind of foolproof. It makes the decision making. You're not sitting back trying to, I got to figure out all this stuff I got to add. You can sit down and literally map out, this is what my application is going to have in it. And then that maps pretty directly over to your database structure. And then as you want to add to your application, you realize, okay, now I'm going to add this particular object for whatever reason. Well, now I can just map that through, and I'm going to need a object table for it. I might need a meta table for it. What are all the other relationships it's going to have with other objects? I need relationships tables for each one of those relationships. So again, it helps, just a systematic way of doing this. Now, one thing to keep in mind with this is, I work with WordPress a lot, so I use it as an example, but if you look at its database structure, you're going to see this. You're going to see the posts and post meta and users and user meta. You won't see categories. You'll see terms. They call them terms. They lump tags and categories and all that stuff into one and have a way of doing that. But as big as WordPress is, as complex and as advanced and all the things that it does, it has, I think it's 11 tables. So it's 11 tables that power the whole thing. And again, they're user meta, post meta. I think 4 of them are just for the way that they do terms and do categories and tags and so forth, because it's a little different, more complex way of doing it. But so it's really actually a pretty simple and straightforward database structure for what is a really kind of complex and advanced application. So hopefully that helps you. If you're still a little bit unclear, I recommend kind of going back through it and the video and actually following along with that sheet that you printed out. Think of an application you might want to build and go through and actually write it down. That's going to help you to kind of put some meat on the bones of this and actually get some experience doing it. And I think once you do that, you'll have a lot clearer picture of exactly what you need to do in order to build a scalable, flexible database structure that makes it easy for you to build and grow and scale your application. All right, thanks for watching. We'll talk to you next time.